Part A. In a cricket match, a fast bowler delivers a ball without hitting the ground. Full toss ball with horizontal velocity 35 meters per second at a height of 2 meters from the ground level as shown in the figure 1. The ball travels a horizontal distance 17.5 meters before touching the bat. Assume there is no air resistance. Part 1. How long will it take for the ball to touch the bat? We have to consider, we know that horizontal velocity is constant for the projectile motion. Therefore, we can use horizontally S equals ut. Distance 17.5 meters, velocity 35, it is constant for the horizontal motion. We have to calculate the time. Now time is 0.5 seconds. We have to bring 35 to the left hand side, then answer is 0.5 seconds. 17.5 divided by 35. Then part 2. At what height from the ground will the ball touches the bat? Now we can consider the ball is moving in a path like this. And we know that initial height 2 meters from the ground level. And we can consider initial vertical velocity is 0. There is a horizontal velocity. It is 35 meters per second, but there is no vertical velocity. Initial vertical velocity is 0. And we have to find this height. I will consider this height as y. Then we can use an equation to the motion under the gravity between A and B. Then I will use A to B. We know that initial velocity is 0. We have to find the distance. Initial velocity 0. We have to find the distance. It is the problem. And we know that acceleration is under the gravity. It is 10 in downward direction. And we know that time is 0.5 seconds. It is found in part 1. Now we can use S equals ut plus half at squared. Initial downward velocity is 0, therefore ut term is 0. We have to find S value is y, half into acceleration 10 times 0.5, but we have to get the square of time. Half squared, it means 1 over 4. Then we can simplify it. 10 divided by 8. 10 divided by 8, 1. 2 remaining, 20 divided by 8, 2. 4 remaining, 40 divided by 8, 5. 1.25 meters. It is the y distance. But we have to find height from the ground level. Therefore, height from the ground level. We have to subtract 1.25, this value, from 2 meters. 2 minus 1.25, 0.75 meters. In part 3, calculate the speed of the ball just before touching the bat. Give your answer to the nearest first decimal place in meters per second. You may take root 2 as 1.41. Before touching the bat, we can get horizontal velocity, it is constant, 35. And we have to get downward velocity. We have to calculate downward velocity. Then I will consider downward velocity as v. Then we can use an equation between A and B in downward direction to find the v value. We can use between A and B, A to B, v equals q plus at. We have to find final velocity. Initial velocity 0, 10 times we have found time is 0.5. 10 times 0.5, 5 meters per second. Now we know that components 5 and 35. We have to calculate the resultant velocity. When calculating resultant velocity, we can use the equation r squared equals p squared plus q squared plus 2pq cos theta. Or we can use Pythagoras theorem directly. We can get final velocity. I will consider it as v naught. V naught is 35 squared plus 5 squared root. 35 squared 1225, 5 squared 25 root. 1250 root. Now they have given root 2 value. Therefore we can write this one 625 into 2 root. Now we know that 625 root value is 25. Root 2 given as 1.4. Now we have to multiply 25 into 400, 0, 10 remaining, 25 into 1, 25 plus 10, 35. 35 meters per second. It is the resultant velocity before touching the bat. 25 into 1 point, they have given 1.41. Then 25 into 1, 25, 2 remaining, 25 into 4, 100 plus 2, 102, 10 remaining, 25 into 1, 25 plus 10, 35.25. We have to give answer to the first decimal place. Then we can get it is 35.3 meters per second. We have to round off it. Then rounding off, the removing number is 5. If the removing number is 5 or greater than 5, we have to add 1 to the remaining part. Part 4, the ball approaching perpendicular to the bat is successfully hit the batsman so that it rebounds and returns in the same incoming line with the same speed. As it approaches the bat, if the mass of the ball is 0.16 kilograms and time of contact with the bat is 0.2 seconds, calculate the force exerted on the ball by the bat. Give your answer to the nearest first decimal place in Newton. Now there is a collision. For a collision, we can calculate force for a collision by using Newton's second law. According to the Newton's second law, force is equal to the rate of change of linear momentum. They have given ball is colliding with the bat like this. Before the collision, its speed is 35.3. And after the collision, it is rebounding with same speed. In the question they have given, there is the same speed. Now, we can get force on bat. I will consider force on bat. It is equal and opposite to the force on ball. We can write force on bat should be equal to rate of change of linear momentum of ball. MV, rate of change of linear momentum of ball. I will write rate of change of linear momentum. It means change of momentum divided by time. When getting change of momentum, mass into final velocity 35.3. It is in this direction. We have to subtract mass into initial velocity. It is in opposite direction. Therefore, we have to consider it as a minus value 35.3 divided by time. Now we can substitute time. You know that minus into minus plus. Then we can simplify this numerator. 2m into 35.3 divided by time is given as contact time 0.2 seconds. It is less than 1 second. Therefore, we can consider this force as an impulse force. 0.11. Mass of the ball is 0.16 kilograms. 0.16 into 35.3 divided by 0.1. Then we have to multiply it. 353 multiplied by 16. 16 to 3, 18, 1 remaining. 16 to 5, 30 plus 1, 31, 3 remaining. 16 to 3, 18 plus 3, 83. 16 to 3, 18 plus 3, 21. 1 into 3, 3. 1 into 5, 5. 1 into 3, 3. 8, 4, 6, 5. 5, 6, 4, 8. Now I have considered without decimal places. There are 3 decimal places in the numerator. We have to put 1000 to the denominator. There is only 1 decimal place in denominator. We have to put 10 to the numerator. Then 56.48 Newton. It is the force on bat. We have to give the answer to the correct first decimal place. 56.5. Removing number is 8. It is greater than 5. Therefore, we have to add 1 for this remaining number. 56.5 Newton. It is the force on bat, and or we can consider force on bat equal and opposite to the force on ball. Then part B. Cricket batsmen use mechanical bowling machines to practice in the net for improving their skills. A certain bowling machine consists of 2 identical heavy wheels, A and B. Fitted with rubber tires. The radius R of wheels with tires is 50 centimeters. The top view of the setup is shown in the figure 2. Each wheel is driven by its own electric motor, but in opposite direction. They are mounted in a horizontal plane with a gap in between 2 wheels. The gap is slightly less than the diameter of a specially designed uniform ball. Part 1. For sending a spinning ball, the rotational speed of wheel A and B are set omega 1 640 rpm and omega 2 560 rpm respectively, while keeping the plane of the wheel horizontally. RPM denotes number of rotations per minute. The linear velocity v of center of mass of the ball is given by v equals v1 plus v2 over 2. The angular velocity omega of the ball is given by omega equals v1 minus v2 over 2r, where r is the radius of the ball. v1 and v2 are velocities of surface of ball at contact points. The radius of the ball r is 4 centimeters. Take pi as 3. Part 1. Calculate the angular velocity omega 1 and omega 2 wheels in radius per second. We have to consider there are 2 wheels A and B. same radius 50 centimeters. Same radius 50 centimeters. And this one is rotating to this side and this one is rotating to this side. Ball is between the A and B wheels, and due to the rotation of A, ball could be obtained V1 tangential velocity and V2 tangential velocity due to rotation of B. Now we have to calculate angular velocities omega 1 and omega 2. They have given RPM values separately. They have given RPM values. We have to calculate omega. Omega means angular velocity. We know that RPM, revolutions per minute, divided by 60 equals RPS, revolutions per second. It is frequency of the object. Frequency is 1 over period. Period is 2 pi over omega O, 2 pi R over V. T is 2 pi over omega, then 1 over T is omega over 2 pi. T is 2 pi R over V, then 1 over T is V over 2 pi R. Now we have to find the angular velocity by using RPM. Therefore, we have to consider these two terms. Then RPM value for the first wheel 640 divided by 60 equals omega divided by 2 phi. Phi value is 3. It is given in the question. We have to consider it as 3. 2 into 3, 6. We can cancel out with this one. Omega 1, 64 radians per second. Now, omega 1 means angular velocity of A, 64. I will mark answers obtained in the diagram because of I will erase calculations. Then omega 2. When finding omega 2, we have to use same method. Angular velocity is omega 2 for B, wheel B. RPM value of wheel B is given as 560. We have to divide by 60. RPM divided by 60 equals, we have to calculate omega. 2 phi value is 3. Again we can cancel out 56. It is omega 2. This one is omega 1. Omega 2 is 56 radians per second. Our angular velocity for B is 56. Then part 2, calculate the linear velocity V of center of mass. Cm means center of mass. Center of mass of the ball when ejected. They have given a velocity for center of mass, but when finding velocity of center of mass, we have to calculate V1 and V2 first. V1 and V2 are tangential velocities corresponding to two wheels. Then I will calculate V1 value. We know that V equals R omega. V equals R omega. Then for the first wheel, V1 equals radius 50 centimeters. It means 0.5 meters. We have to substitute in SI unit. Omega 64. 5 into 4, 20. 2 remaining. 5 into 6, 30 plus 2, 32. We have to separate one decimal place. 32 meters per second tangential velocity for A. Then tangential velocity for B. V2 equals, again radius 0.5. Angular velocity of B is 56. 5 into 6, 30. 3 remaining. 5 into 5, 25 plus 3, 28. We have to separate one decimal place. Meters per second. Now we can get velocity. Linear velocity of the ball. It means linear velocity of center of mass. It is not a theory we have studied, but they have given velocity V equals v1 plus v2 divided by 2. We have to add linear velocities. 32 plus 28 divided by 2. 2 plus 8, 10, 1 remaining, 3 plus 1, 4 plus 2, 6, 60 divided by 2, 30 meters per second. It is the linear velocity of center of mass. Part 3. Calculate the angular velocity omega of the ball in RPM when ejected. Again we have to calculate in RPM. They have given. Then we have to use radius. Radius of the ball is 4 centimeters. 4 centimeters we have to convert it to meters. Then I will use 100 to the numerator. 32 minus 24, 28, 4 divided by 2 into 4, 8 into 100. 50 radians per second. It is the angular velocity of the ball. Now we have to convert it to RPM. Again we can use RPM relationship. RPM divided by 60 equals omega value is 50 divided by 2 into 3. Now we can cancel out 10 into 50. RPM value is 500. RPM 500. Now part 4. If the mass of the ball is simple m, write down an expression for the total kinetic energy of the ball when ejected in terms of m, r, v, omega. The moment of inertia I of the uniform ball of radius r about an axis to the center is given by I equals 2 over 5 mr square. We have to get total kinetic energy. Total kinetic energy means linear kinetic energy, sum of linear kinetic energy and rotational kinetic energy. Part 4. Total kinetic energy. We can write linear kinetic energy half mv square plus rotational kinetic energy half pi omega square. And we have to substitute I value. Moment of inertia of the sphere is given as 2 over 5 mr square. 2 over 5 mr square. Into omega square. We can cancel out 1, 2 terms. Half mv squared plus mr squared omega squared divided by 5. It is the equation. They have asked that kinetic energy of the ball in terms of m, r, v and omega. If they have not given omega, we have to substitute omega by using v equals r omega. Now they have given omega in the question, therefore we can write this one as the answer. Then part 5. When the ball ejects, calculate the maximum speed that the point of the surface of the ball can have. Maximum speed of a point of the ball. We can use v equals r omega for the ball. We know that omega value is 50 radians per second. We have to calculate velocity. V equals radius 4 centimeters, omega value 50. 2 meters per second. But this is the tangential velocity. We have to consider maximum resultant velocity. It means This ball is rotating in this direction and it is moving with a velocity 30 meters per second. Now you can identify there are two velocities corresponding to this point. First one is due to linear motion, 30 meters per second. Second one is due to rotational motion, v. Now we have to get maximum velocity as the sum of these two velocities. Therefore, maximum velocity 30 plus 2, 32 meters per second. We have discussed 5 parts for the part 1 of B. Now there is another part, part 2 of B. For sending a fast ball without a spin, angular speed of the ball of the wheels are set equal so that omega 1 equals omega 2 equals omega naught. To eject a fast ball, velocity of 35 meters per second, what should be the angular velocity? Angular speed, omega naught of each wheel in RPM. When given a fast ball, it means ball is not rotating. Tangential velocity of the ball should be 35 meters per second. It means this V1 value and V2 value should be 35 meters per second. It is not spinning. If there is a difference between these two velocities, the ball will rotate. But now ball is not rotating, therefore ball should have the same common tangential velocity for these 2 points. Then we can consider motion of the ball. Tangential velocity is 35 meters per second. To give a tangential velocity 35 meters per second, tangential velocity of the wheel also should be 35 meters per second. Therefore, we can use V equals R omega to a wheel. V value should be 35. Radius of the wheel is 0.5. Omega value is omega naught. We have to calculate omega naught. It is the common angular velocity of both wheels, A and B. Then 0.5 is half. We can bring 2 to the right hand side. 35 into 2 equals omega naught. Now 70 radians per second is omega naught. Or we can calculate it, now we can calculate it in RPM. We can write relationship again. RPM divided by 60 equals RPS. It is frequency 1 over T. T equals 25 over omega. Therefore 1 over T is omega over 25. RPM value, we have to calculate RPM value. Omega value is 70 divided by 2 into 5 value is 3, it is given in the question. RPM value is 700. It is the answer for part 2.